In fact, my subject is quite different from the subject presented by Dr. Mukhtar. I will talk about science and technology. And basically, I will emphasize where we are heading in the coming decades, centuries, and millennia. Now, I will not go through all the content, but I will try to see what are the drivers of the fourth industrial revolution and beyond, what we are expecting in the future. Now, the first industrial revolution started in the mid-18th century, and of course, there are certain drivers for this revolution. This revolution was outlined by British textile industry, and we have machine tools, steel manufacturing, etc. The second industrial revolution, we have the radio, the telephone, the television, home appliances, generation of electricity, etc. The third industrial revolution was the invention of the transistor. I was always asking my students, what is the greatest invention by man in history? And the answer was always, not always, but they give different answers to this question. But personally, I think that the greatest invention in history is electricity. And the second thing that comes in line is the transistor. Transistor was invented in 1947. It revolutionized the whole world. Everything we are doing today, all the technology is based today on the transistor. Of course, there is the laser, which coming as well. So in fact, yeah, it has no, the 5G is a part of the fourth industrial revolution. Yeah, 5G is a part of the fourth industrial revolution. 5G, in fact, is not only speeding the processes, but also speeding the networking, and it has big impact on Internet of Things and other. Okay, a third industrial revolution, in fact, the invention of transistor, etc. Now, they give different answer. They say the base is the television, the car, etc. The airplane. But this is not the answer. All these are based on transistor. So in fact, the transistor is at the heart of all the technology we are witnessing today. Yeah, I'm coming to this point. The fourth industrial revolution by new technologies, the blockchain. We have the Internet of Things, intelligence, and robotics, advanced materials. This is by itself is a huge topic. Additive manufacturing and multidimensional printing, nanotechnology. This is also a very important part that will shape the future. Virtual and augmented realities, etc. In fact, what are the drivers of the industrial revolutions? These industrial revolutions are not coming from nowhere. The first industrial revolution was basically based on our understanding of thermodynamics. Thermodynamics, this gives rise to understanding how we build machines. And then, of course, we have, in the second industrial revolution, we have the theory of electricity and magnetism, which is electromagnetic theory. And this also paved the way for the third industrial revolution. Now, what is important is the third industrial revolution, because it is the basis of all subsequent industrial revolutions coming in the future. In 1900, there was one scientist. He was interested in one problem. If I have a piece of metal and I try to heat this piece of metal, what will happen? I will have radiation coming out of this metal. Now, if the color of this metal will change. from red to blue, etc. So in fact, he was wondering, this spectrum that gives me all these colors, where it comes from? He tried to solve, a lot of scientists tried to solve this problem mathematically. They've been unable to find an answer. Now what Planck did, he assumed that this material absorbing in a form of quanta. Quanta, I mean, نسميها لقيمات يعني in patches. Einstein rejected this definition. No, it is the radiation itself. It consists of small things that he called photons. In fact, that was the birth of the quantum theory. Many scientists. You have most of the theories are developed by one scientist. For example, general relativity, special relativity are developed by Einstein. But the quantum theory, there's about 20 scientists who participated in developing the whole theory and putting it in the shape that we understand it today. Quantum theory was understood in the 20th of the 20th. Now, based on this, we understand the basic technology of semiconductors. Semiconductors are the basic of all what we are using today as technology. Now, later on, after the quantum theory, what we have? Quantum theory is at the heart of nanotechnology. Now, this idea of nanotechnology, the word nano is 10 to the minus 9. Okay? So nanotechnology is based on everything which is of this dimension. Now, the problem of nanotechnology that at a certain dimension, the physics is not the same. If I have, for example, a piece of gold, I will see it as a piece of gold. But a very small piece of gold, it will not have the same color. It will have different color. This is just one example. Now, this nanotechnology is so important that USA invested 3.7 billion. This is 3 to 4 years ago. European Union 1.2 billion, and Japan 750 million. So from these figures, you can have an idea how this subject is important. The application of nanotechnology is in medicine, electronics, biomaterials, energy production, new materials, microfabrication, space science, etc. And we are always saying that in 20 years' time, everything you have will be based on nanotechnology. The medicine, your mobile, your TV, your appliances at home, all will be based on nanotechnology. Now, this is, as I said, when we apply quantum mechanics to nanotechnology, we'll discover, for example, if I take a very small piece of copper, it will not look the same. It will be transparent. If I take, for example, aluminum is a metal, but at very small scale, it is flammable. Gold becomes soluble. So you can see that the features and the characteristics and properties of materials will be quite different at the nanoscale. Nanotechnology, of course, there are many disciplines related to nanotechnology, the bio-nanotechnology, the nanotechnology in energy production, the nanoengineering, nanotechnology in military system, nanotechnology in desalination, in medicine, etc. Electronic devices, and telecommunication. Now, I will go back to the lecture of yesterday, your lecture, about the publication. All these publications you can see in China, they are approaching the number of papers produced in nanotechnology, and all these papers are in Chinese. So in fact, there is a big competition between United States and China in producing uh, papers or new research work in nanotechnology. Now, Dr. Abdullah, you asked me about the transistor. Transistor is the more slow, and what dimension of the transistor? Uh, we can talk about 10 nanometers, 7 nanometer chip in the coming 3 years. But if I use the carbon nanotubes, this is the development in nanotechnology, I can go to about 1 nanometer. 1 nanometer, 1 billionth of a meter. Okay. Now beyond this, it is difficult. Beyond this, because the quantum effect is so strong, and I cannot go beyond this scale. I'm limited by quantum effect. Of course, nanotechnology has also uh, application in medicine. In medicine, I can direct the what you call it, the medicine. I can direct directly to the uh, cell, okay, and I can repair the cell from cancer, from any other. Now, other development is MEMS. Now, these MEMS, if you look at it, it is just a piece of dust. But if you put this piece of dust under the microscope, you will see another story. In fact, you will see another world. In this piece of dust, you can see a whole system of devices, etc. And these could be applied, especially in military. They have military application. And as you can see, for example, these are some of the MEMS in form of insects. I'll go a little bit fast. Energy and nanotechnology. Also, nanotechnology can be a big contributor to the energy systems in the world. And this is very important topic that is emerging 50 years ago and now developed to uh, a certain development which will impact the uh, human mind in the future. What is this? In fact, I can identify and read what the brain is sending as waves. Okay, and detecting these waves, I can read what you are thinking about. And this is very important. If I can read what you are thinking about, this will change the whole social social, political, etc. And this is coming very strong in this technology is coming. Okay, I will go to the future. What will happen in the year 2050? Yes. No, what is happening now? No, no, the transistor and nanotechnology, they are going in parallel. That means nanotechnology apply also transistor in. Yeah. No, this one is what we call it neuroscience or neurotechnology. Neurotechnology, no. Neurotechnology is how to read what you are thinking. You know, the brain is sending signals. Now, if I can read the signals, I can read I can know what you are thinking about. So if two politicians sitting in front of each other, and every politician has his devices in his pocket, so I can think what you are thinking, and you can think what you can tell what I am thinking about. So this will be, huh? It is telepath. It is telepath. Yeah. Yeah. I will come to this point. I will come to this point. Now, another development we are expecting in 2050 is what we call the space elevator. The space elevator, you have an elevator, which is simple, what you call it, simple cable coming from Earth up to a distance of 36,000 kilometers. So, in fact, this elevator take you from Earth to a height of 36,000 kilometers. And of course, it has many applications. It has military applications, but also you can launch satellites, you can launch rockets, you can make a station to going to the moon or other planets using this technology. Now, this technology, in fact, maybe you say it is a fiction. No, it is not a fiction. There are a lot of companies around the world working on this technology, and there is a conference held every year to see what are the new developments of this space elevator. The countries which are involved in this are Europeans, Japanese, and Americans. No, to my understanding, not yet. Now, I will talk about the future. In 1911, there is a scientist called Onnes. What Onnes did? At that time, we know helium. Helium is a gas. But the technology was such that we can transform this gas into a liquid. So liquefying helium gas. The helium becomes a liquid. Now, when helium becomes a liquid, its temperature drops to 4.2 Kelvin. 4.2 Kelvin, that means minus 269 degrees centigrade. Now, Onnes, what he did, he took a piece of mercury and put it in this liquid helium and measured the resistance of the mercury. And he discovered something very strange. The resistance becomes zero. Oh, resistance zero. This is very interesting. So other scientists later on tried to obtain materials, other than mercury, that gives a temperature, that gives a resistance of zero. Until 1986, there are a lot of materials developed trying to make higher and higher superconducting temperatures. The best they find is about 136 Kelvin. 136 Kelvin, this is very low. 136 Kelvin, I can give you the conversion of this. Is around minus 166, minus 160 centigrade. Now, what happens is that in 1986, two scientists from Switzerland, you can see to the left is Penrose, and to the right is Alexander Müller. You can see also the difference in age between the two. He is in the 70s, the other in the 30s, and they developed a new material. Now, this new material, it is superconducting at a temperature of 35 Kelvin. 35 Kelvin is 12 Kelvin higher than the previous record. And they've been awarded the Nobel Prize. Now, later on, just a few months later, scientists used the same method and obtained for BISCO 107 Kelvin and for IPCO 92 Kelvin. We worked a lot on this material at the University of Bahrain, and we published over 20 papers on this subject. And I can say at that time, we are the first group who published in the Middle East a paper on this subject. Now, the question is, why superconductivity? Why superconductivity is important? I am asking my students, the most important invention in recent time is the transistor. What is the next? The next is simply room temperature superconductor. If you can realize a room temperature superconductor, this is the way how to be a billionaire, not a millionaire. If you want to be a billionaire, try to obtain a material which is superconducting at room temperature. This will revolutionize all technology we are having, from your car to your TV to your computer. Your computer will be 100,000 times faster with zero resistance, with using superconductor than using, Victor, you are aware of this. So in fact, superconductivity now, there's a big work on superconductivity all around the world. And please, I don't know if there are students here, please, this is something that you have to look at. That will change the world. No, the most recent I received a few days ago, it is minus 23 Kelvin. Sorry, minus 23 centigrade. If this is true, then it will be under pressure. Yeah, but a news like this, you see it in the TV and in the street. Yeah. Huh? You will see it in nature. Huh? Yeah, you will see it in nature. Yeah. No, this you have to check, because such a news will revolutionize. Okay. I will show you this. This is the data. This is the data. In fact, this is 1 year old, and the best superconductor we obtain is minus 70 degree centigrade 1 year ago. But 1 month ago, it was minus 23. Now, the other development that will change the world in the 50s is the nuclear fusion. Fusion, yeah. This is I'm looking at the, nuclear fusion is how to mimic what is happening in the sun. We bring the sun on Earth. Now, this fusion, why we are talking about fusion, not fission? Fusion will give you clean energy. This is the difference. So we can obtain clean energy and inepuisable source of energy. So you can have energy free. There is a lot of development. This two projects started in the 70s, last century. One in the United States and the other in Russia. In Russia, they use a tokamak machine. In United States, they use lasers to produce fusion. So in fact, these are the laser, fusion laser. Now, I would like just to talk about the human mind. The human mind is in a cage. You cannot think beyond this cage because you are limited by your senses. So in fact, the question that scientists are asking, what is reality? Is the reality of the human mind in this cage, or there is a reality out of this cage? And this is a big debate. So in fact, when we are talking about superstring theory, we are talking about something beyond the cage of the human mind. Now, the human mind can perceive the world through our senses. And our senses are three-dimensional. So everything we can perceive is three-dimensional, plus one dimension of time. So we are talking about four dimensions. Now, this superstring theory is a problem. This explains everything we know in science. But there is one problem, that this theory talks about 11 dimensions, not only 3 or 4 we are talking about. So in fact, mathematicians, such as the mathematician I have in front of me, Dr. Bakr, they said, no, these extra 7 dimensions, we find the trick to remove them. We reduce them to 0. And this is called in mathematics compactification. So the 7 dimensions that we don't perceive, the mathematician said, okay, we get rid of them by compactification. Myself, I think that there is a limitation of our senses, a limitation of our mind, and something we don't perceive is not there. So reality is beyond what our mind is thinking about. What we are perceiving in this world is not the reality. We are perceiving the projection of reality on our world. It is the projection of reality, but not the whole reality. The whole reality is beyond our senses. And I think that in the future, to be a cosmic civilization, we have to really try to explore these extra dimensions. And just 1 minute to see where we are as a cosmic civilization. Now, there is Kardashev scale to classify cosmic civilizations in terms of how much energy they are consuming. Now, type 1 civilization is consuming 1.74 10 to the 17 watt. Now, this is about 100,000 times what we are consuming on planet Earth. Okay? Type 2 civilization is consuming 410 to the 26, and type 3, 410 to the 37. So, in fact, type 1 civilization can harness all the energy produced by the sun. For example, if I take Earth as an example, by the planet. Second type civilization by its sun, and third type civilization is by all the energy available in the galaxy. But I think energy, this is a classification of Kardashev, but I think that energy is not the only factor that determines the classification of civilization. There is also the ability of innovation. Energy you have, but you have to have innovation, in fact, to become a cosmic civilization. Now, the question is, yeah, I thought a message was sent to me. Yeah, I think that the Earth will be a cosmic civilization in the coming 200 years. So in the 200 years, we will become a cosmic civilization of type 1. We are type 0 now. In 1,000 years, become type 2, and in 10,000 years, become type 3. والعلم عند الله. Thank you very much.